Okay, guys, let's do this problem together. Here, I've got given f, I've got some f values, I've got some f prime values, and I want the equation of a tangent line. So if I want an equation of a tangent line, what do I need to do? I need a point and I need a slope, right? So I'm going to write this down. I need a point and I need a slope. Okay, I've got lots of points here. So how do I know which point they want? Right here, right? It says find the equation of the tangent line to f of -1 at x equals 3. So I need the point where x equals 3. Now be careful here, guys. This actually is not f. Just because you see f here doesn't mean that this point is a point on the function f. Here it says find the equation of the tangent line to f of -1. All right, so this is the inverse function of f, and I'm going to cross it out and call it g. And I'll put in a note here that f of -1 is equal to g, or f and g are inverses, basically. All right, because I don't work well with f to -1, but I work really well with g. Okay, so what they want here is they want the equation of a tangent line to the inverse function of f, which is called g. All right, so make sure you understand this is not an f tangent line on f, but it's a tangent line on g. Okay, on the curve g. And what else do I know? If I know this is the curve g, what's the slope of the tangent line? If this is g, then this is going to be what? G prime. And in the parentheses here, what value would go in this parentheses? Remember, we always said the x value goes here. Okay, you could have the x comma y value, but you would never put the y value here. All right, so let's put the x value here, and this x value is 3. Now, how do I find the y value of g if I know the x value of g? Well, this is the big hint here. F and g are inverses. So if f and g are inverses, then what they have is corresponding points. So what point do I know here? I know that the curve g has a 3 something. If the curve g has a 3 something, what does the curve f have? It has a something 3. Right? So if f has a something 3, could I figure out what this x value is? If f of x is 3, what's x equal to? And I go up here and I say, yeah, here it is. F of x is 3 when x is 2. So you put a 2 here. That means you put a 2 here. And this point here then is 3 comma, this is a point on g, 3 comma 2. Okay, and that's all because f and g are inverses that we can figure out what this point is. If you get numbers for the point and if you get numbers for the slope, then you can go ahead and write the equation of the tangent line. I do have numbers for the point, but I don't have numbers for the slope. How do I solve g prime of 3? Yeah, according to our formula sheet, if g and f are inverse functions, okay, then g prime at a point is equal to 1 over f prime at that corresponding point. Okay, and the question is, how do I figure out what number goes here? And it's not 3. It's not the same unless it's a coincidence. All right, so when g has an x value of 3, then what does f have an x value of? 2. It's right here. So I would put 2 in these parentheses. And so the question is, what is 1 over f prime of 2? Because if I can figure that out, I can figure out the slope. So 1 over f prime of 2 is 1 over, right here, -4. So the answer is -1/4. All right, let's go ahead and write the equation of the tangent line. It's y minus y is equal to the slope times x minus x. And there is my answer. Okay, let's do some homework questions together. If we look at your integration worksheet, and I want to look at number 35. This is the integral of x over the square root of x squared minus 5 dx. I want to go through this and see if we can figure out what the answer is. If you think that this whole thing down here is your u, so if you say u is equal to the square root of x squared minus 5, okay, which is x squared minus 5 raised to the 1/2, by the way, that means du dx equals, make sure you take the derivative of this properly, it's 1/2 x squared minus 5 raised to the -1/2. Don't forget to multiply by 2x. So this is really, let's see, the 2's cancel out. This is really x over the square root of x squared minus 5. Now if I solve for dx, I get dx equals du times, okay, I'm cross multiplying. So the square root of x squared minus 5 du over x. All right, I'm just cross multiplying there to solve for dx. Okay, so what two things do I replace? I replace my u and I replace my dx. Everything else I leave the same. Okay, so this would be the square root of x squared minus 5 over x du. And the question is, using real algebra, do all my x's cancel out? These x's cancel out to 1. Does this cancel out? No, so I have to use implicit integration. Do you know how to do implicit integration? Me neither. You can't do this. This means I picked the wrong u, or it means I did something wrong, or I should have manipulated something else before I started this problem. So it turns out I actually did pick the wrong u, okay? U here should not be the entire bottom. I actually know it's not the entire bottom because if u is the entire bottom, then this would have been an ln problem. And so I would have to divide here by the derivative of u, which I have right here. So if I divide this by x over the square root of x squared minus 5, do my x's cancel out? Well, the x's cancel out, but do all my x's cancel out? No. So therefore, this is not an ln problem, meaning I cannot make u the entire bottom. That would be incorrect. Let's start all over then. What should I make u? Well, you just try different things, and one of the things that you could try is that u is just equal to x squared minus 5. All right, if that's true, then du dx would be 2x, and dx would be du over 2x. All right, I replaced two things. What two things do I replace? My u, which is now just the inside part here, and my dx. All right, so if I rewrite this, this is x over the square root of u times du over 2x. If I simplify, what I get is 1/2 the integral of 1 over the square root of u du. Did all my x's cancel out? Yes. Okay, so I can work with this now. So at this stage, I should be, every time you do u substitution at this stage, after you substitute in and cancel out, you should have a problem that you could do easily by just taking the reverse power rule, or this is on your formula sheet. One or the other. Is this on my formula sheet? No. Is this something I could do with reverse power rule? Yes. I add 1, divide by 1/2, which is the same as multiplying by 2, and then I just write what I have left. 1 times u to the 1/2 plus c, and there is my answer. Okay, it's just the wrong answer. I need to go back and replace my u. So my u is actually x squared minus 5 raised to the 1/2 plus c. And that's a little bit awkward, but that's a fine answer. This is probably a little bit better notation. Okay, and there's my answer. All right, I'd also like to look at number, let's look at number 36. Can you do 36? Okay. I can see students saying, what do I make my u? Well, let me try making ln of x ln of x my u. Okay, then I need to take the derivative of both sides. The derivative of x ln of x is the derivative of the first times the second plus the derivative of the second times the first, which is ln of x plus 1. If I solve for dx, okay, what I get is du over ln of x plus 1. I substitute two things. I substitute my u. Let me get that in a different color. I substitute my u and I substitute my dx. Oh, I substitute everything here. So this is going to be 1 over u times, and dx is du over ln of x plus 1. And the question is, do all of my x's cancel out? No, they don't. Okay, so that means I need to go back to the drawing board, manipulate this somehow so that it'll cancel out. Or maybe I picked the wrong u. Okay, what else could I pick for u here? Try ln of x. And if you pick the wrong u, you just keep on going. You just keep on trying until you find a u where the x's cancel out. You keep on going. So if you're unsure, you just keep on trying something else. Something will work, because all these problems, they're specially concocted, so u substitution works. Okay, sometimes you have to do back substitution, but most of the time, plain old u substitution works. All right, so du dx equals, what's the derivative of ln of x? Okay, it's the derivative of the top divided over the top, okay, over the top. So then I solve for dx, so dx is actually equal to x times du. I just cross multiplied there. And then I replace two things. What do I replace? I replace my dx and I replace my u. So this x here doesn't get replaced. So when I replace everything, what I get is 1 over x times u on the bottom, right? So try that again. On the bottom, I have x times u, and dx is actually equal to x du. Do my x's cancel out? Yes, they do. X divided by x is just 1. So what I get here is the integral of 1 over u du. And is this something that's on my formula sheet, or is it something I can do an easy reverse power rule? Okay, if I see it as an easy reverse power rule, what I'll do is I'll add 1, divide by ding, 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 ding. There's an ln bell. That means that this is an ln problem. That means that this is actually on my pink sheet. The integral of 1 over u du is actually ln of u plus c. And so there is my answer. It's just the wrong answer. Okay, I need to go back and put in my u. There's my u right there, ln of x. And I have now the right answer. All right, let's do one more problem. Let's do number 39. Okay. If we look at 39, what we have is the integral of 2 over tangent 7x dx. Okay, if you say that u is equal to tangent 7x, if you take the derivative of both sides, what you get is 7 secant squared 7x, because the derivative of tangent u, remember, is secant squared u du dx. Okay, and that du dx is the 7 right here. And then you solve for dx, so dx is du over 7 secant squared 7x. All right, so I'm going to substitute two things. What two things am I going to substitute? My dx and my u. And so what I get here is an integral of 2 over u times du over 7 secant squared 7x. And then I ask myself the question, do my x's cancel out? I've got a secant squared 7x over here. Does it cancel out with anything? No, it doesn't. So this is not the right u, or I did something wrong. Okay, it's not the right u. I need to choose something else for u. What else could I choose for u? Let me try 7x. Okay, that means the derivative of u is 7. That means dx is du over 7. Okay, over here, I would get 2 over tangent u times, let me make sure I'm doing the right things. I'm going to replace my u, and I'm going to replace my dx. So this is 2 over tangent u, and dx I know is du over 7. Okay, so if I take out the scalar, what I get here is 1 over tangent u du. And this must be something that is on my formula sheet. Is it? Well, not in this form, but isn't 1 over tangent the same thing as cotangent? And cotangent is on my formula sheet. The integral of cotangent, remember cotangent is really cosine u over sine u. Okay, and I could take the ln of that. So we're going to take the integral of that and it becomes an ln problem. So this becomes the ln of sine u plus c. And since the s doesn't start with a c, there would be no negative here. So this is my answer. Okay, it's a great answer. It's just not the right answer. What do I need to do to make it right? I need to go in here, replace the u with the 7x. Okay, and now I have the right answer. Okay, so guys, we're going to use this new formula that we know, and that's the derivative of e to the u. Oops. The derivative of e to the u is e to the u times du dx. Okay, the weird thing about what we're doing now that we didn't do before is now our u is actually the exponent. The exponent is our u. Okay, so this is going to be the derivative. Well, let me just say, all the u's now are x's. Okay, so if this is an x, then this is an x, then this is an x. Okay, so what's the derivative of e to the x? It's e to the x times dx dx. What's dx dx? 1. So this is just e to the x times 1. Okay? What if instead of x, I put in 2x? So here this would be 2x, this would be 2x, and this would be the derivative of 2x. So what would be the derivative of, oh, let me make sure this is y prime equals e to the x. I'm taking the derivative. Sorry, it's not y equals. So y prime is equal to, what's the derivative of e to the 2x? It's e to the 2x times the derivative of 2x, which is 2. So do you see that would be 2 times e to the 2x, right? So all you do is you basically just take the derivative of your exponent and put it on the side. Okay, so what's the derivative of this going to be? Y prime. What's the derivative of u? 2x plus 5 times what? E to the x squared plus 5x plus 7. And this should be in parentheses because this is the entire du dx. E to the u times du dx. Does everybody see how easy that is? Okay, so why don't you guys do this one then? What's this derivative going to be? Y prime. If I have e to the sine x. The derivative of sine x is cosine x times e to the sine x. Super easy, right? Okay, how would you take the derivative of this? Give me some suggestions. You have a similar homework question. Any ideas? Some students might say, well, let's just move this up here. But be careful, when you move it up here, this is not the incorrect way to move it. I'm just letting you know. Okay, if you multiply, if you want to change the exponents to a positive and negative, it cannot have a plus sign in here. Does that make sense? Okay, so you could move it up, but you have to do something different. You guys want to do quotient rule or product rule? That's the first question. Quotient rule or product rule? Product rule. If you want product rule, you have to move the bottom up, right? If you move the bottom up, you have to realize that this is a family. Okay, so when you move the family, you got to move the whole family. So this would be e to the x, e to the negative x quantity raised to the negative 1. You guys good with moving families? Okay, it's important. We don't break up families in calculus. Okay, so we're going to keep them together. All right, then we're going to do product rule. Actually, since this is just a 4, do you see you could just do chain rule? Everybody good with that? So let's do the chain rule here. So the derivative of f will be 4 times negative 1, which is negative 4. Leave the inside alone. Okay, take the power down by 1. Guys, if I'm at negative 1 on the number line, where will I be when I go down by 1? Negative 2. And then take the derivative of the inside. Okay, do you see this is just a buy one, get one free problem because there's a plus sign. What's the derivative of e to the x? E to the x. What's the derivative of e to the negative x? Negative e to the negative x. Why? Because it's e to the u times du dx. So this is negative x here, and this is the derivative of negative x here. So this is negative 1 times e to the negative x. Okay? And pretty much this is your answer. You can't simplify these because this is a plus sign and this is a minus sign. You know what I'm saying? You can't combine them. But you could, if you wanted to be totally technical, negative 2 in the power is not simplification. And so negative 4 e to the x minus e to the negative x all over. Now I'm just going to move this term or this factor here to the bottom. So e to the x plus e to the negative x and get a positive exponent just so that, this is totally simplified. But again, on my test and on AP test, this would be fine. But you would need to know this for multiple choice tests, okay? And also if you go to college and your professor is picky about those type of things, okay? All right, let's do a tougher one. Let's see. Do you guys feel like you could do this one? Okay, go ahead and do this one. This one's not super terrible. Find space on your paper or something, try to work this one. So the derivative of e to the u, remember, is e to the u times du dx. So what you really do is you just copy this. This is your e to the u times, what's the derivative of your u? So make sure you understand now that exponent is our u. What's the derivative of negative 4x to the negative 1? 4 times x negative 2. Okay, and that's your answer. And if you really wanted to simplify it, it would be 4e to the negative 4 over x squared. Okay, pretty easy? Okay, let's do this. You're going to see this probably on your test. But you'll see it again and again. Okay, if I want to take the derivative of an ln problem, do you agree that the derivative of ln of u is equal to u prime over u? Okay, well, where's my u here? That's my u, right? So if I wanted the derivative, if I wanted f prime of x, that's, the ln's going to drop out, right? When you take the derivative of ln, the ln drops out. There's no ln in sight on the derivative side. So what's the derivative of this u? Negative 8x minus 7 times what? E to the negative 4x squared minus 7x. You guys good with that? But don't forget to divide by u. Your u is e to the negative 4x squared minus 7x. Do you see what cancels out? Yeah, this whole e thing cancels out. If you use real math, okay, everything's being multiplied together, so these cancel out. So what you get is negative 8x minus 7 is your answer. Anybody see a shortcut on this? Oh, what happens when you log a tree? Do you guys see the logging of a tree right here? What happens when you log a tree? The apple falls out, okay? Guys, but here's the thing, make sure. This is not the answer. The apple is not the answer because you want to take the derivative of it. What's the derivative of negative 4x squared minus 7? Negative 8x minus 7. Okay, so if you ever see an ln of e, notice that the apple falls out, or if you tree a log or log a tree. But be careful, guys. This is with derivatives, okay? And so you can do it either way, both ways work. But when you see this on an integral, you really have to see that the apple falls out of the tree, or else it'll be an impossible problem, okay? So in this way, you can take the shortcut or the long cut. But when you see integrals, you really have to take the long cut. Okay, why do we even do derivatives? Well, to find maxes and mins, of course. Okay, so let's see if we can do this one, and you'll definitely see a problem like this again. Okay? I don't know. It's fine. Okay, find the minimum value of f of x. Okay, find the minimum value of f of x. So here we go. How do I find minimum? Guys, is minimum absolute min or relative min? Now I'm forgetting. If I just say minimum, it's absolute min. How do you find an absolute min? Canada's test, or what's the other choice? If there's only one critical point. One. Do you remember that one? And the slope is always positive on one side and always negative on the other side. And that, therefore, is that relative min is the absolute min, okay? Or the relative max is the absolute max. Okay, since I have no endpoints here, what I'm going to do, because Canada's test, you need endpoints, I'm going to try to do this one critical point method, okay, which is the first derivatives test method. Let me just go with it, okay? It worked in the other two periods. Maybe it'll work in this period too. Okay, so here we go. I'm going to do the first derivatives test. How do you do the first derivatives test? What do you think you do first if it's called the first derivatives test? You take the first derivative. Okay, how do you think you take the derivative of x times e to the x? Product rule. Here we go. Derivative of the first times the second plus derivative of e to the x, which is e to the x times the first. So everybody go with that. So there's my first derivative. What do I do with the first derivative? Set it equal to 0 or dne. Okay, why do I do this? To find what? My critical points. Okay, so I do this to find my critical points. Whatever x is equal to, those are going to be my critical points. All right, over here, how am I going to solve for x here? You could guess and check, but you might be guessing for a long time. Any idea how I can solve, like isolate the x here? Take out e to the x. If I take out e to the x, I get something times something equals 0. And in math, if something times something equals 0, what does that mean about one of these somethings? One of them is 0. Okay, there's no way you can get an answer of 0 if one of these is not 0. So what I know is e to the x is equal to 0, or 1 plus x is equal to 0. If e to the x is equal to 0, what's my x equal to? What x value would cause this thing to be 0? What's e to the 1? Would that cause it to be 0? No. Okay, what about e to the 2? No. What about e to the negative 2? Would that be 0? E to the negative 1. How do I get this to be 0? Guys, graph e to the x. What does e to the x look like?
It never.
Is it ever 0? No, this is no critical point. Another way you could tell is, how do you get rid of an e?
You
log it. Okay, if you log an e, what happens? The apple falls out. And so what you'll get is ln of 0. Go punch in ln of 0 into your calculator. Okay, what is ln of 0? It never hits 0. Okay, so guys, this is no critical points. There's no answer for x that was satisfied this equation. Over here, guys, what's x equal to? Negative 1. All right, so I've got at least one critical point. Okay, let me go over here. Over here, you'll see that there are no denominators, so I make a denominator. And if I cross multiply here, I'll also get something silly. So I'll say that's also no critical points. Okay, is everybody good with that? So I only have one critical point, which is good because I've got that special justification. Remember, if I have one critical point and the left side looks like this and the right side looks like this, then that is the absolute max or absolute min. Okay, so let me go ahead and put in my number line. Okay, what kind of number line is this? Is this an F number line or an F prime? It's an F prime number line. Okay, then you're going to test numbers to the left and right. What's a good number to test to the left? Less than negative 1. Negative 2. Greater than negative 1. 212. Okay, so we're going to go over here, and if you remember, this was our F prime. You may or may not remember. This was our F prime. It's a lot easier to plug in this than to plug in this one. This one is also F prime, but it's harder to figure out. This one, since they're multiplied together, you could just figure out positive or negative. If I plug in negative 2, okay, is this positive or negative? What's e to the negative 2? This is where students make mistakes. Is e to the negative 2 negative? There's a negative in it. Is it negative? No, guys, e to the x is never negative. And another way to remember it is this is 1 over e squared. Is 1 over e squared negative? No. So this is positive. What about 1 minus 2? Negative, so this will be negative. What about if I plug in 212? If I plug in 212, is e to the 212 positive? Of course. And what about 1 plus 212? It's positive. So I have positive, positive. So what I have is decreasing, increasing, and that's my f. If this is my f prime, this is a picture of what my f looks like. I don't know exactly, where it starts and stops, but I do know f is in another room and it looks something like this, okay? If it looks something like this, and I only have one critical point, what does that mean is happening right here at negative 1? That is the absolute min. It definitely already is the relative min because the f prime changes from negative to positive. But it's also the absolute min because when x is less than negative 1, f prime is negative. When x is greater than negative 1, f prime is positive. So therefore, this relative min is the absolute min. So I get an absolute min at x equals negative 1. Did I answer the question?
No.
What was the question?
It says find the value.
Find the value. So find the what value? The x value or the y value? The y value. If they're asking for minimum value or maximum value, you're actually looking for the y value. Which equation do I plug in to find the y value? Do I plug in my f prime or do I plug in my f of x? My f of x. I want the y value on f, okay? So what I'm going to do is I'm going to put in negative 1. So this will be negative 1 e to the negative 1. Okay, so this answer is negative 1 over e. Hopefully you would recognize that on a multiple choice test. You good with that? So the integral of e to the u du is equal to e to the u, right? If the derivative of e to the u is e to the u, then the integral of e to the u is e to the u. So pretty easy to remember, okay? But what you need to know is when we walk backwards, we actually don't do this problem. When we walk backwards, we actually replace this with an x. And we say that this is e to the u divided by du dx plus c, okay? So this formula here is used in u substitution. This formula down here is used in walking backwards or pattern recognition, okay? And so let's think about it. When I take the derivative of e to the u, I write down e to the u, and I multiply by du dx. So wouldn't it make sense that when I take the integral, I write down e to the u, and I divide by e to the du dx, right? The derivative of u. So all I'll do here is I'll say, you know what? Figure out what your u is, okay? And if it is a reverse e to the u problem, then your u is your exponent, okay? I'm going to box that in, okay? And then I copy the e to the u. So e to the u is e 3x plus 1, okay? Now I need to divide. Remember, in derivatives, I multiplied by 3, right? So now I need to divide by 3. Does that make sense? The tricky thing about integrals, though, is your x's must cancel out. So not counting what I boxed in, not counting the e to the u, do my x's cancel out? Yes. So this answer is 1/3 e to the 3x plus 1 plus c. Okay? Now some of you guys are like, whoa, wait, how did we do that? Let's just do it with u substitution. It also works. U substitution always works before Christmas. Okay? So your u, if you think that this is an e to the u problem, your u is going to be 3x plus 1. The derivative of that is 3. If you solve for dx, what you get is du over 3. Okay? You replace two things. You replace your u and you replace your dx. So what you get here is, go ahead and erase this. What you get here is the integral of e to the u times du over 3. I'm going to pull out my scalar. And at this point, always, always, guys, you need to have an easy reverse power rule problem or something that's on your pink sheet. Okay? Is this on my pink sheet? Yes. It's the integral of e to the u, which is what? E to the u. And there's your answer. Okay, but you notice it's not the right answer. Why not? Because you need to put your u back in. Okay, but it's the exact same thing as when we did pattern recognition. So make sure you put your u back in. All right, so let's do another problem. And let me show you how to do this. Do you guys want to do u substitution or pattern recognition? Okay, if you do pattern recognition, make sure you do this, though. This is where students go wrong. Box in your e to the u. Okay, because everything else has got to cancel out. Your e to the u can stay, but everything else must cancel out. Otherwise, you pick the wrong, u. Okay, this makes this your u right there. Okay, what's the derivative of negative x squared? Okay, so I'm going to divide by the derivative. Okay, so first, I'm going to copy my e to the u. Then I'm going to divide by the derivative. Do my x's cancel out? Yes, so this becomes negative 5/2. Copy your e to the u, and don't forget Charlie. Okay? If these x's do not cancel out, you got to start all over and pick another u. Does that make sense? All your x's are not going to cancel out every time. Okay? Let me see if there's a more fun problem. This one's pretty fun, actually. That one's fun, too. Let's do this one. Okay, do you want to do u substitution, or do you want to do your pattern recognition?
Oh, pattern recognition.
Anybody want to do something else? Okay, let's do pattern recognition. If you do that, then box in your e to the u. You're saying that this is an e to the u problem. Now, your x's has got to cancel out. If they don't, you got to do something else. That makes automatically this your u. Okay, remember this is really x to the negative 1, right? What's the derivative of x to the negative 1? Negative x to negative 2. So you have to divide by negative x to negative 2, which is really multiplying by negative x to the 2. Does that make sense? I need to divide by negative x to negative 2, which is really multiplying by negative x to the 2. Is everybody good with that? Okay, so if I multiply by negative x to the 2, not counting what I boxed in, do all my x's cancel out? Yes, but I have what left over? A negative e to the, and you copy your e to the u, and you add Charlie. Okay? And again, guys, I don't really recommend doing e to the u on this problem. I would actually try u equals 1 over x, okay, and take the derivative of that. I think it's a little bit easier to do. This would be negative x to negative 2 dx equals, this is actually negative 1 over x squared. So when you cross multiply here, dx is going to be negative x squared du, which I think is easier to do than the pattern recognition. But it's up to you how you want to do it. You're going to replace two things. So this would be e to the u over x squared times negative x squared du. Do my x's cancel out? Yes. So what you get is negative integral eu du. And you have to tell yourself, is this an easy reverse power rule problem? Or is it something on my pink sheet? Something on my pink sheet. So the answer is negative EU plus C. and that is my answer. It's just the wrong answer. You go back and put in your negative 1 over x. But other than that, you're good. Okay? All right, so the problems can get pretty tricky. So this is a problem that's tricky. Okay, and I think you have an example somewhere like this on your worksheet also. If you pick that this is my u, I'm just letting you know it's not going to work. Because what's the derivative of 2? I'm sorry, what's the derivative of 2x? 2. When I divide by 2, do my x's cancel out with this? No. So do you guys see that picking u equal to 2x is incorrect here? So u would not be 2x here. So you have to figure out something else. So this one you pretty much have to use u substitution, okay? So what would your u be? It's not going to be this 2x, okay? So what is it going to be instead? Yeah, actually, the easiest thing to do is make it the entire bottom. Okay, guys, you remember what I told you? When you make your u your entire bottom, what type of problem does it become? An ln problem. So you could do the shortcut on ln if you remember it, but let me just do the long way here. If you take the derivative of both sides, what's the derivative of 1? 0. What's the derivative of e to the 2x? 2e to the 2x. Solve for your dx. This would be d to the u. du. Okay, then you replace two things. You replace your u, and what else do you replace? Your dx. Everything else stays the same. So this would be the integral of e to the 2x over u times du over 2e to the 2x. Do my x's cancel out? Why, yes, they do. So I'm going to pull out the 1/2 scalar, and I get du over u inside. Okay, remember, when you do u substitution, this should be a problem that's an easy reverse power rule problem or something on your pink sheet. Is this on my pink sheet?
Yes.
Yes. What is the integral of du over u? Ln of u. So it's 1/2 ln of u plus c, and there is my answer. It is just the wrong answer because you need to go back in and put your u. But do you see this is my u here? So I'm going to go back in and put in 1 plus e to the 2x inside these absolute value symbols. And then you'll be good. Okay? How are you guys feeling? Good.
So good.
Go ahead and, no, I don't think you have much time. I'm just going to let you know your homework is not easy. It looks easy when I do things, but that's just because I'm doing it and I've done it for several years. Okay? So, but it's the same method. And if you get it wrong, it's because you're picking your u wrong. And I could tell you on every problem, this is your u, this is your u, this is your u, and you'll get it right. Does that make sense? But the hard part is picking your u, okay? And the more practice you have, the better you get, okay? And I'll put some solutions online for you guys.